Hey, hi everyone. I'm Priyabrat and I welcome you to this video. And this is the part of the series building AI agentic application for life science and the first video. And basically in this video, we will talk about introduction about the AI agents. So basically what are AI agents mainly? So before jumping into agents, so let's see about the AI journey that I will talk about, like how the evolved. So before this, all this machine learning was there. Initially, statistics was there. Probability, t-test, z-test, those kind of. So that was the era of statistics, where using statistics we were trying to understand the data, right? Like the shapes, those kind of thing. Then came the era of machine learning, so where we basically we build different algorithm and we train the machine to do lot of problem. For example, to solve many problem like classification. For example, we were training the machine to, like, okay, this is an apple, this is tomato, and apple is like, it's a hard, tomato is soft, both are red color. So we were giving different features about an apple and then tomato, and machine was learning how to differentiate apple versus tomato. So this was the machine learning era, where many algorithms came, like support vector machine, came nearest neighbor, logistic regression, those kind of things were there. And then came the neural network, is another machine learning algorithm was there. And then came the era of deep learning, where the same neural network algorithm, but multiple layers of hidden layers were there. And using this neural network, we were trying to understand trying to understand the hidden patterns in the data, and trying to understand the data, and from there we were able to solve many problems. So that was the era of deep learning. But till that time, like when the generative AI was not there, the main neural network was recurrent neural network. So that has only one problem. I can tell that, let's say you are reading a book, so by the time you come to the second paragraph, you used to forget the first paragraph. So that was the main problem of not able to solve like memorize kind of thing. Long term relationship between words was not there. And then came a very landmark paper from Google, that's the transformer paper. This changed the game actually. And not only this paper, its algorithm, but at the same time we had GPU was availability was there. So that means we had the hardware competition, because this all this generative AI requires a lot of computations. Lot many parameters are required. So that's where you need compute power. So due to the availability of this hardware GPU and the algorithm, Google's transformer paper, everything changed. That's very nice paper. For example, let me show you. This is the paper. This is called "Attention is All You Need." So that means in order to understand something, you have to pay attention to particular words in the input or in the context, we say. Okay, so this paper is I'll not go into the technicality, but this is the paper that changed from where uh, uh, this large language model came. So if, as I said, like that example I gave, right, when you were reading the second paragraph, you used to forget first paragraph, right? But with this transformer algorithm, you were not able to forget. That means you were able to remember everything in that book. So that way you are machine learning models, or you can say that the model were able to remember everything about the this thing. And that's where these models were trained on the large corpus of the text. That's where this foundation model came into picture. And like the basic, the GPT model, those kind of things, like OpenAI, chat GPT, all these, right, those are the foundation model came, which were trained with entire human knowledge. Okay, so now the model got trained, they know about everything about human language. But still they had some lot many problems at this stage. So because they were hallucinating. For example, if a model was trained up to 2022, they will not know what happens in 2023, and they will try to hallucinate. And then that was one more problem was there, and that got resolved as on improving the models. And something landmark, another breakthrough came, that is something called reasoning model. So this came from the deep seek, the paper. So that paper, when they introduced, that's where they introduced a very nice word, something called thinking. That means if you allocate more thinking time to a problem, model is able to think, reason it, and then they were able to solve a complex problem. Basically, if you give a complex problem to any model, the model now can think, and they can break down the complex problem into small steps, and then they will be able to do that. So that's where, from the foundation model came now the reasoning model, where in that model have, chain of thoughts. That means the model can now think, given a problem, they can now think, okay, this is how, okay, now they can plan, and then they can act. So that led to the agentic era, because now the agents can now think, they can plan, and now they can act. So because of that, the shift came, and then came the agents, right? And that's where you used to call like tools, any tools you will be able to run it. The agents were able to run many tools or MCP, those kind of things. These are the topics that I will walk through, but that's where the agents. So agents is nothing but they can think, reason, and they can plan, okay, this is the problem, I will break down like this, and then they can act. So that's how the evolution of AI journey came. Okay, so now before agent, let's talk about what actually LLM. LLM is, as I said, it's a large language model. That means model trained with large language of the human text. Okay, basically generative AI means they generate the next token. Basically, they are good at generating the next token. So for example, very simple way, if you see, if I ask like today it is going to be which day, so then there is equal probability that it might be rainy day, it is sunny day, and chilling day, right? All three are the equal probability. So that's why whenever you run first time, let's say the model might say that it's a rainy day, but if you do the second time, it might tell sunny day, because equal probability is there. That's why these LLMs are non-deterministic. That's a very important one. That means every time you might get a different results. Okay, but if you provide more context to an agent, okay, to an LLM, you will get a very highly accurate result. For example, let's say if I now change the sentence like I got my umbrella today, it is going to be which day. So now you see that now the LLM will pay attention to this particular word umbrella, and based on that it will now most likely it will say that rainy day would be the highly probable answer. So that's where attention is all you need, the Google's paper, right? So that says that you have to pay attention to the umbrella word, and based on that it is going to predict the next token. And that's what, as I said, like context is very important. And in all agents, everything, if you want to get a correct answer, you have to be very, very specific towards your questions and prompts to all these agents, and that means instruction to these agents. And so LLMs are mainly non-deterministic, because every time you put, they might give you some other answer based on the probability of the next token. Okay, so that's why better the context or prompt, and better or accurate results you will get. So that's how that's why prompt plays a very important role in this field of agents. So if your prompt is accurate and very to the point, you will get a correct more deterministic, I would say. So now we'll learn about LLM. They are the generative token. They will tell. So now let's say what are agents. So in simple term, agent is nothing but LLM plus some tools. So LLM is nothing but the brain of that agent, and tool is nothing but the capability. Okay, so let's take an example. Okay, let's say there is a chef is there. If you ask that chef, hey, can you cook me some biryani for me? So agent will say that, okay, I know how to cook the biryani. So you do this, you do that, then you will cook a biryani. Agents will give you the knowledge about how to cook a biryani. But now you ask agent, hey, I'm providing you the kitchen, I am providing you knife, I am getting you all the ingredients. Now can you cook biryani for me? Now agent see that, okay, I have the knowledge about how to cook the biryani, and I have all the tools also. So now I can cook it for you. Now the agent will go plan. So now that's the three-step process. It will reason, okay, the user has asked me to cook biryani. He will think, okay, I have to cook the biryani. So let's plan it. So it will plan it. Okay, step number 1, then 2, then 3 and 4. Then it will actually act. So that's the important thing. So LLM plus tools, that means the capabilities, is nothing but an agent. And we need a reasoning model. That means though we should use those models which are able to think. That means they will be able to break down the complex problem into simple thing. So we need those kind of thing. Okay. So that's what same way for agent to uses LLM to think, then plan, and uses tools to act. So reason, they plan and act. Okay. So let's take an example. So if you ask a user ask what is 2 to the power 25. Now if it is an LLM alone, they cannot do it because they generate text, right? Okay. So but an agent, they can do it. Why? There is a difference, you see. Now let's say if you provide some simple Python function, let's say power function, which can calculate the power of number. Let's say there is a function you have written power 2 to the power 25, or let's say any number you pass and to the power any number you pass. Let's say you have written this function which will able to calculate power of any number. So now what this agent will do, basically agent will generate a text. That's a very important. Okay, agent will generate a text that okay, the user has asked me the question 2 to the 25 and I have a tool. That means I have this capability called power function which can where I can pass this to number and I will get some answer. So basically what that agent will do, agent will generate a text for the function calling. So let's say if you do it, let's say if I will provide you a function and I will ask you, can you do that? So what you will do, you will write this power 2 to 25 and you will run it in Python interpreter and you will get the results, right? That is what agent is doing. That agent is also basically generating this simple text, and this function is actually running in your system and it is running in a local system. Let's say if you're running it's locally and you're getting output, and that output is again feeding it to the this one to the model, and you are getting the output that okay, that the power of 2 to the 25 is this one. So you see how it works. When you ask a query, LLM thinks okay, I have a tool called power, let me call that. So now it generates a text called power 2 to 25 and then that is executed in our system, and whatever output we get, that output and this query mixed and the response goes back to the user. That's how. So in short summary, agent is nothing but a brain. That means the LLM, the model, and the capability is nothing but the tools. So now let's say a little deep dive. So what are AI agents? Agents as first thing we need a brain. So that means in order to build an agent, we need a brain. So that's where we specify which model to use. Let's say if you are using OpenAI, you can use GPT 4.1 or 5, any model you can use. Or if you want to use Google Gemini model, so you can use that model. So those are the brain. So and that means those are the LLM model, that's the brain. Then next what we need to is like something called system prompt. This is what defines that agent, the persona. So we have to tell agent what he is. Okay. So for example, you can tell that you are a software developer. So that means you are giving that power to that agent that okay, he is a software developer. So he will now think through as a software developer. Let's say if you say that you are a joke teller. Okay, so that means you are giving, say that this agent, you are a joke teller. So now when you tell an agent that you are a joke teller and you ask any question, right, he will always answer in a joking fashion because you told him that you are a joke teller. That's how the system prompts works. Like that is the main definition of like what an agent is all about. So you can say that that's a persona, like every character style is different, right? So you can say that that's the agent style of doing. Okay, that's very important. That's a system prompt plays a very, very important role. What an agent can do or what an agent cannot do. That's where we are strict guidelines we can put, like okay, this is what you are. You are a joke teller, means you have to tell jokes only, kind of thing. We are restricting that agent to in that particular this thing. Okay, so we need a brain using which it can think. Next you have to tell what that agent is all about. That means the persona. Then you provide some capabilities. Let's say, as I said, the power function, or let's say search clean var. You have written a some function clean var which will go to database and it will do something. So now if you ask an agent to do something related to clean var, that an agent will be able to do that because you are provided the capability to that agent. Now what we need is like we need something called memory, because see, you have asked an agent, then if you want to ask further question, that agent needs to store that conversation somewhere, right? So that's where we need to provide that agent some memory, and the memory can be either short-term memory, that means till the time you are interacting the chat session, the memory will be there, and persistent means you can store that history persistently. For example, let's say in Netflix, when you are watching, right, it remembers like what you have watched, and based on that it recommends, right? So if you want to remember what you have talked with the agents, so those you need to store those persistent memory kind of thing. And then if you need, you can further empower your agents with called MCP. MCP is model context protocol. We'll talk about that, but you think that MCP is nothing but some tools developed by some people. Okay, basically you are using it. Let's say there is something called PubMed MCP server. Let's say the PubMed guys have built some tools where you can query the PubMed, get the paper, search the abstract, and do those kind of things. So basically they have already developed it. Why you want to develop it? Basically you simply use them, right? So that's where we need a protocol to connect our agent to that MCP server. So that's what so if we link that PubMed MCP server to our agent now will be empowered with further tools. These tools are nothing but you have provided custom written, that means you have flexibility to provide the tool, and here this is nothing but someone has already developed, we are simply connecting and using it, those kind of thing. And then one more concept is called guardrails. So basically this is just check, so let's say you are creating an agentic application for life science use case, but let's say the user can ask like, can you provide me some review about this movie or some entertainment? So then in that case the agent should say that I cannot answer that, something not related to life science. So that's where we are putting an input check, that's called guardrails. In same way we can put some output check, that the agent should not output something, let's say offensive or something, so we can put something output check. So those are called guardrails. So these are the 6 main core concept of LLM, an agent. So we need a brain, the model, the system prompt is the persona, what that agent is, and some additional capability, that is you write some capability to the agent, and you need to provide some memory if you want to retain that conversation, and if you want to equip some tools that is developed by some other people, you connect it to MCP, and you can have some checks for input and output. So these are the 6 core concepts of any agent. So using these 6 you will be able to build it. Okay, but the bare minimum is like we just need the LLM, the model, and the system prompt. Even if we do not have tools, memory, MCP guardrails, we will be able to build an agent. So in this course we will see, we'll iterate like progressively. We will learn, like we'll start with agent with the prompt, then we'll add some tools, then we'll see like how to learn memory, then MCP guardrails, like that. But in short, you go any agentic framework, these 6 concepts will be there. You learn OpenAI, you learn Crew AI, anything, any framework, all framework must provide all these 6 things. So that's what, let's talk about the different agentic platform that's available using which you can build. One I said like OpenAI framework, that we will be doing in this course. Apart from that, you have this LangChain, Langsmith, LangGraph, those family kind of thing. So that also is a good framework, core Python based, but very steep learning curve. You need more core concepts, but it gives you more flexibility, more control, where you can control your agent, more deterministic, and so less autonomy, those kind of thing. So where more control if you need, so that's a good platform. Crew AI is another very popular open source as well. They have the open source framework to build agents. Microsoft has AutoGen to build the frameworks, and Pydantic AI, and many more. Like even if you go for Amazon has Strand, which is very much similar to OpenAI. I will be conducting more videos around that later on. But yeah, so Amazon has its own Bedrock agents, core, those kind of thing. But in short, any framework used doesn't matter, everything will fall under the same thing. Like you need a model LLM, we need a system prompt, you need to provide some tools, and if MCP is optional, guardrails and memory, everything revolves around that. So if we learn one, you will be able to switch to other framework by simply learning the syntax. Okay, that's all. And yeah, and yes, so okay, so that's all about that was all about the agentic platform. Now come to the first part, the brain, the LLM. So now there are different types of LLM models are there. Like as I said, the reasoning models, coding models, different types of models are there. But reasoning models are best suitable for these tools and agents. So we'll be using that. And different LLM model providers are like OpenAI, Anthropic, and all different Google Gemini kind of are there. So if you are using their framework, so it's a paid, so you have to pay for that. If you are using OpenAI model, you have to pay, and it's all about per token basis, how many input token and how many output token you are consuming. Also the rate limit depending on your tier level, how many times you can hit those API, those kind of limitations are there if you are using with like this paid models. But if you want, there is an alternative is there, something called local ollama models, where everything, this LLM model will run on your laptop local system, and we will see like how to download the ollama model and use that, and without paying others, you can play around this agentic, everything you can do it. But only thing, like, it runs on your local system and it's very slow because it's running on your laptop. But the only thing, is free, you don't have to pay anyone, it's just compute. So but it's possible to use both, local model as well as the paid model as well. So with that, as I said, we in this course we will be mainly focusing on OpenAI Agents SDK platform, and it's a very Python based. We will be using that to build agents. So let me click these links and show you about that. Before that, I have the course in my GitHub repository, where I have created the very basic course that we will be going through. I will share this link on the description so that you can look into the codes. But yeah, so this is the OpenAI SDK agent. This is the Python package that we need to install to make it work, and we need some basic setups that, as I said, like I have this notebook where all the setup instructions are available, using which we need we can do that. So what we need, like, we'll do Visual Studio, and we need Python, and we need to install UV, and some basic packages we need to create a virtual environment and activate it, and within that virtual environment you can install all the packages. Basically we need this OpenAI agents, so that's the agent from the OpenAI framework, and some other framework we need. Particularly we need OpenAI Python library, Gradio, and other we need for other application. I will talk about that. So yeah, and some other is optional depending on the use case. What we'll do, particularly for one use case, we will be needing is optional. But main thing is like OpenAI. Okay, so we need to an API key from OpenAI, because we will, since we are using their framework to build these agents, right? So we need to go to OpenAI and sign up, and then API key. So I have created an account here in OpenAI platform, and so go to API keys, and you can create a new API key. So this is this you give a name, let's say test2, and the default project, and give all permission, and you can create a secret key. So this will you can copy this and store it somewhere, and this will need it. Okay, so this is the first thing what we need, the API key. And as I said, if you go to usage, right, so you will get a $5 free credits by them, and number of tokens, I think beyond 1 million token or something, I think your tire will change, but that is more than enough for playing around this course, because I have tried so many things, and mostly we'll be using local model. Like as I said, you can use local model to run all this thing, so all the whatever the course we will do, we can use the local model as well. But still, as I said, $5 is huge, like for all these courses and all. Okay, so go to OpenAI platform, create an API key, store it somewhere. That's all we need. Okay, and this is the setup link. And yeah, so as I said, we need to also need local models, right? So we need to install Ollama. You can go to this link and install. Basically, if just let me go there. So this is the Ollama repository on Linux. You just type this one, and it will just install Ollama, and you start the server, and you can pull any model, Ollama models. Okay, I will just say about Ollama, just 1 minute. Let's see, Ollama, right? So this is the Ollama web page. So where you see these are the models are available, right? These are the different LLM models, the brain, and these are all free. Okay, and what we will be using something called GPT OSS. So this is a open source model by OpenAI, and we will be using this 20 billion parameter model for doing this. As you say, this is designed for reasoning, so that agent can think, and agentic task, and they can use tool calling, those kind of things. So that's where we'll be using this one. And for this we need, I think, minimum 14 or 15 GB RAM in your laptop to be free to work. And yeah, So yes, I have given the instruction, and as I said, like if you encounter any issue, don't worry. Again, you can go to Chat GPT or Gemini and ask like, I am facing this issue, like how to install Ollama, how to install these packages, how to create a virtual environment. These are very common thing, and so I would suggest to use UV for, because this is ultra fast package manager, which we can use to install all these this thing. So instruction is very simple. It's not very tough kind of thing. So that's all about this thing. So next we'll move to the next one, that is about building the agent directly. We'll go to the practical. I hope you got an idea. I just summarize what I talked, like agents are nothing but LLM plus tools, and agents can reason, plan, and act. So they think, they plan, then they act. So these are 3 steps, and these are the 6 capabilities. We need a brain, system prompt, the tools, and memory, and MCP, external connectivity, Guardrails, some checks. So these are the 6 core concepts, and any framework you use, doesn't matter, all follow the same thing. But the learning curve of each framework is different, and we will be using the OpenAI framework. I hope you liked the video, and if you have any queries, you put in the comments. I will try to answer it, and I will see you in the next video, where we will directly do the practical of using few simple steps to build an AI agents. Thank you. See you in the next video.